Question 1. From the perspective of diagnosing intermittent system slowdowns on an Oracle Linux 6 server, Mr. Davis notices significant wait events in the Oracle Wait interface, primarily related to I/O. He suspects inefficient buffer cache usage. What should Mr. Davis do to confirm and address this? A. Analyze vSystem event to identify top wait events and tune the buffer cache size accordingly. Increase the PGA size to reduce shared pool contention. C. Disable automatic shared memory management to manually tune SGA components. D. Focus on CPU utilization metrics and ignore wait events since I/O waits do not affect performance. Answer. Correct answer. A. Explanation. Mr. Davis should focus on wait event analysis using dynamic performance views like vSystem event to identify the exact nature and frequency of waits. Since wait events relate to I/O, buffer cache tuning is essential. Adjusting its size to reduce physical I/O waits, increasing PGA size or disabling ASM does not directly impact buffer cache efficiency. Ignoring wait events would miss the root cause. EU metrics alone are insufficient for I/O bottlenecks. This approach aligns with performance tuning methodology emphasizing diagnosis via wait interface and relevant views before corrective action. Question 2. Taking into account the deployment of Oracle Database on Oracle Linux 5 wants to automate collection and analysis of workload statistics but does not have a licensed I/O repository. What tool should she use to fulfill this requirement? A. StatSpec utility to gather performance snapshots and reports. B. Automatic workload repository for automatic snapshot management. C. SQL Access Advisor for index recommendations. D. Database replay and real application testing for workload capture. Answer. Correct answer. D. Explanation. StatSpec is the preferred tool for Oracle Linux 5 environments without an I/O license, providing manual snapshot collection and reports to analyze performance over time. I/O is not available in unlicensed environments. SQL Access Advisor provides index tuning unrelated to workload data collection. Database replay, part of real application testing, captures workload but is not primarily a stats collection tool. Isli's scenario requires StatSpec as it fulfills the need for performance data collection without extra licensing. Question 3. In light of recent developments, Mr. Kumar observes that AECRI on Oracle Linux 6 occasionally changes its execution plan during runtime. What mechanism is likely responsible, and how should Mr. Kumar interpret this behavior? A. Adaptive execution plans dynamically adjust during execution to optimize performance. B. Static execution plans are cached and do not change, indicating a bug. C. SQL plan management locks execution plans, preventing changes. D. Optimizer hints override any dynamic plan changes. Answer. Correct answer. D. Explanation. Adaptive execution plans can change at runtime, adjusting plans based on real-time statistics, improving performance for unpredictable workloads. Static plans do not change, so their presence suggests no runtime adaptation. SQL Plan Management (SPM) is designed to stabilize execution plans, preventing unwanted changes, not causing them. Optimizer hints direct the optimizer to follow specific paths and can prevent adaptive changes. Mr. Kumar's observation aligns best with adaptive plans behavior and less overridden by hints or SEM. Question 4. When considering resource allocation on an Oracle Linux 6 server running multiple Oracle databases, ISING wants to prevent one session from monopolizing CPU resources. What feature should she configure? A. Database Resource Manager to allocate CPU and other resources. B. SQL Tuning Advisor to optimize all SQL queries automatically. C. Automatic Memory Management to balance EGA and SGA. D. Real-time Database Operation Monitoring to visualize workloads. Answer. Correct answer. C. Explanation. Automatic Memory Management (AM) adjusts memory dynamically but does not allocate CPU resource. SQL Tuning Advisor optimizes SQL statements but does not manage CPU allocation. Real-time monitoring aids visibility but not resource control. Database Resource Manager is specifically designed to manage CPU and other resources among sessions or consumer groups, preventing resource monopolization. ISING should configure Resource Manager to enforce CPU allocation policies. Question 5. Given the circumstances of a high transaction system, Istio O'Neill wants to reduce the overhead caused by frequent passing of similar SQL statements. What Oracle feature best addresses this problem? A. Shared pool tuning to ensure passed statements are cached efficiently. B. Buffer cache tuning to reduce physical I/O. E. SQL plan management to freeze execution plans. D. In-memory column store for faster analytical queries. Answer. Correct answer. B. Explanation. The best approach to reduce parsing overhead is tuning the shared pool to efficiently cache passed SQL and execution plans, avoiding repetitive parsing. Buffer cache tuning focuses on physical I/O, not parsing. SQL plan management stabilizes execution plans but does not address parsing frequency directly. In-memory column store accelerates analytical queries, not alt parsing. Istio O'Neill should optimize the shared pool, ensuring sufficient memory and minimal fragmentation to reduce parsing overhead. Question 6. Considering the evidence from recent performance reports, Garcia notes that some SQL queries have execution plans with high costs and many full table scans. What is the most effective approach for her to improve query performance? A. SQL Access Advisor to get index and materialized view recommendations. B. Increase PGA size to improve operations. C. Use Atom to automatically generate execution plans. D. Disable automatic shared memory management. Answer. Correct answer. A. Explanation. High-cost queries with many full-table scans usually benefit from better access paths. SQL Access Advisor analyzes workload and suggests indexes or materialized views to improve query efficiency. Increasing PGA size helps sort and hash operations but does not directly change access paths. Atom analyzes performance data and recommends tuning but does not generate execution plans. Disabling ASMA may degrade memory management. Garcia's best step is to use SQL Access Advisor to improve access paths. Question 7. Under the assumption that a database experiences excessive latch contention in the shared pool, what is the recommended action for Istio to mitigate this issue? A. Increase the size of the shared pool and consider using bind variables. B. Increase PGA aggregate target to reduce sorting time. C. Disable IA to free up system resources. D. Implement real application testing to replay workload. Answer. Correct answer. C. Explanation. Latch contention in the shared pool often results from insufficient shared pool size or excessive hard parsing. Increasing shared pool size and using bind variables reduces hard passes and latch weights. Increasing PGA aggregate target optimizes session memory, unrelated to shared pool latches. Disabling IA disables critical diagnostic data collection and is not recommended. Real application testing. Workload analysis but does not reduce latch contention, thus increasing shared pool size and using bind variables is correct. Question 8. Within the framework of monitoring a long-running batch job, Brown needs to obtain a granular second-by-second snapshot of active sessions activity. Which Oracle feature should she use? A. Active session history ASH reports. B. StatsBack reports. C. Alert log analysis. D. SQL tuning advisor. Answer. Correct answer. D. Explanation. Active session history ASH captures detailed second-level data about active sessions, ideal for granular analysis of workload. StatsBack provides snapshot-level historical data but lacks second-level granularity. Alert logs record system and error messages, not session activity details. SQL Tuning Advisor provides tuning recommendations for SQL but does not capture active session snapshots. Brown should use ASH reports to monitor real-time session activity precisely. Question 9. Based on the information that a recent system change negatively impacted query performance, Istio Patel wants to compare performance before and after the change systematically. Which Oracle tool best facilitates this? A. SQL Performance Analyzer to test SQL workload impact. B. SQL Plan Management to lock execution plans. C. Buffer cache tuning to reduce IO weights. D. Automatic memory management to adjust memory dynamically. Answer. Correct answer. B. Explanation. SQL Performance Analyzer is used to evaluate SQL workload performance changes, but SQL Plan Management (SPM) specifically captures and preserves execution plans, allowing comparisons and plan stability before and after changes. Buffer cache tuning affects EO but is unrelated to systematic plan comparison. Automatic Memory Management dynamically adjusts memory, but does not provide workload comparison. Mr. Patel should use SBM to ensure execution plans remain optimal post-change. Question 10. Throughout the course of diagnosing database issues, Mr. Williams is examining trace files generated for a problematic session. What is the best use of these trace files? A. To get detailed, low-level information about SQL execution and errors for that session. B. To configure automatic workload repository snapshots. C. To monitor memory utilization statistics globally. D. To generate SQL tuning recommendations automatically. Answer. Correct answer. C. Explanation. Trace files provide in-depth diagnostic details about session activity, including SQL execution errors, wait events, and optimizer decisions useful for root cause analysis. They are not used to configure our snapshots or monitor global memory usage. That is done through other performance views and tools. While trace files assist tuning, they do not generate SQL tuning recommendations automatically. Tools like SQL Tuning Advisor do that. Mr. Williams should use trace files for detailed session-level diagnostics. Question 11. When analyzing a sudden spike in CPU usage on an Oracle Linux 6 server hosting Oracle database, Taylor observes high numbers of hard passes and latch waits. What is the best course of action? A. Enable SQL plan management to stabilize execution plans. B. Increase the shared pool size and encourage use of bind variables. C. Increase PGA memory to reduce sort operations. D. Disable automatic workload repository to reduce overhead. Answer. Correct answer. B. Explanation. High hard passes and latch waits typically indicate excessive parsing and contention in the shared pool. Increasing the shared pool size provides more memory for caching past SQL and execution plans. Reducing parsing frequency, encouraging bind variables allows statement reuse, minimizing hard parsing. Enabling SQL plan management helps with plan stability but does not directly reduce parsing or waits. Increasing PGA affects sorting but not parsing. Disabling I removes critical diagnostics and is not advised. Question 12. Given the circumstances of a multi-tenant Oracle database on Oracle Linux 5, Mr. Chen wants to automate and baseline performance metrics with AI. Which tool fits this requirement best? A. StatsBack utility for manual snapshots and reports. B. Active session history for real-time monitoring. C. SQL Access Advisor for index optimization. D. Database replay and real application testing. Answer. Correct answer. A. Explanation. StatsBack is designed for environments without an IA license, collecting snapshot performance data and enabling baseline comparisons. An active session history captures active session details, but is real-time and transient, not suitable for baseline. SQL Access Advisor focuses on schema optimization, not metrics collection. Database replay tests workloads, but does not automatically baseline performance metrics. Mr. Chen should use StatsBack to gather historical performance data. Question 13. Based on the information that an Oracle Linux 6 database exhibits frequent buffer busy waits, Mr. Ahmed suspects contention on hot blocks. What action should he take to mitigate this? A. Implement table compression to reduce EO. B. Tune the buffer cache to increase size or adjust free lists. C. Increase PGA memory to reduce latch contention. D. Disable automatic shared memory management for manual tuning. Answer. Correct answer. D. Explanation. Buffer busy waits occur when multiple sessions contend for the same data blocks, often on hot blocks or segments. Tuning buffer cache size or free lists can help, but Oracle Linux 6 environments often benefit from disabling ASM to manually tune components like buffer cache for finer control. Table compression reduces EO but does not address contention directly. Increasing PGA memory impacts session, not buffer cache contention. Manual tuning after disabling ASM allows better handling of buffer cache issues. Question 14. Under the assumption that an Oracle Linux 5 server is frequently encountering slow query performance with large sorts, what tuning area should Jackson prioritize? A. Program global array PGA sizing to optimize sort and hash operations. B. Shared pool tuning to reduce parsing overhead. C. Real-time database operation monitoring to view active queries. D. SUL plan management to fix execution plans. Answer. Correct answer. C. Explanation. Large sorts benefit primarily from sufficient PGA allocation, which stores session-specific memory areas for operations like sorts and hash. PGA sizing directly impacts sort efficiency. Shared pool tuning addresses parsing, not sorts. Real-time database operation monitoring provides immediate insight into query progress and resource usage but does not directly improve sort performance. SUL plan management stabilizes plans but does not address memory allocation for sorts. Prioritizing PGA sizing is critical. Question 15. While examining the impact of recent schema changes, Mr. Hernandez wants to understand if statistics are stale and influencing the optimizer. What is the best practice for managing optimizer statistics in Oracle Linux 6? A. Regularly gather fresh optimizer statistics using DBMS stats and lock critical statistics if needed. B. Disable automatic workload repository to avoid stale stats. C. Increase buffer cache to reduce EO during stats gathering. D. Use SUL plan management exclusively to prevent plan changes. Answer. Correct answer. A. Explanation. Maintaining fresh and accurate optimizer statistics is essential for the cost-based optimizer to choose efficient execution plans. Using DBMS stats to gather stats regularly ensures optimizer decisions reflect current data distribution. Locking stats for critical objects prevents unwanted plan changes due to statistics shifts. Disabling hour negatively impacts diagnostics and stats gathering. Buffer cache does not directly affect stats gathering. SUL plan management controls plans but does not replace good statistics practices. Question 16. From the perspective of diagnosing long-running batch jobs is new and wants to identify sessions causing the highest wait times in real time. Which view or tool should she utilize? A. vSession wait to observe current waits per session. B. Alert logs to review historical errors. C. StatsBack snapshots for historical analysis. D. SQL tuning advisor for query optimization. Answer. Correct answer. C. Explanation. vSession wait provides instantaneous details on wait events per session, useful for real-time diagnosis. However, for longer-term trends or historical wait time aggregation, StatsBack snapshots provide a more comprehensive perspective, enabling identification of chronic wait issues. Alert logs record errors, not waits. SUL tuning advisor optimizes queries but does not provide wait event data. Is new and should combine both vSession wait for immediate info and StatsBack for historical patterns, but for this question, StatsBack is the more comprehensive option. Question 17. Considering the evidence of unpredictable query performance, Mr. Lopez suspects the cost-based optimizer is influenced by fluctuating data distribution. How can he stabilize execution plans? A. Use SUL plan management to capture and fix execution plans. B. Disable automatic memory management to manually tune SGA. C. Increase CGA aggregate target for better memory handling. D. Use SUL access advisor to drop indexes. Answer. Correct answer. B. Explanation. SQL plan management is a strong method to stabilize execution plans by capturing and fixing them. Disabling automatic memory management allows manual tuning but does not directly stabilize plans. Increasing PGA aggregate target improves session memory but not plan stability. Dropping indexes typically reduces performance and is not a method to stabilize plans. Thus, SUL plan management, the direct approach, while disabling AM affects memory, not plans. Question 18. For the purpose of improving query execution times on an Oracle Linux 6 server, Miller wants to leverage a feature that automatically adjusts memory allocations between the SGA components without downtime. Which feature is most appropriate? A. Automatic shared memory management ASM. B. SUL tuning advisor. C. SUL plan management. D. Real-time database operation monitoring. Answer. Correct answer. A. Explanation. Automatic shared memory management dynamically tunes SEA components such as shared pool, buffer cache, and large pool, balancing memory usage without restarting the database. SUL Tuning Advisor helps optimize SUL but does not manage memory. SUL Plan Management controls execution plans, not memory. Real-time monitoring provides insights but does not adjust memory allocation. ASM is the best choice for automatic runtime memory tuning SE. Question 19. While reviewing trace files for a high EU session, Foster wants to interpret detailed execution flow and identify bottlenecks. What is the primary benefit of analyzing these trace files? A. They provide low-level diagnostic data on session execution, weights, and errors. B. They automatically generate performance baselines. C. They configure automatic workload snapshots. D. They offer global system memory usage statistics. Answer. Correct answer. C. Explanation. Trace files offer in-depth, session-level diagnostic information including SUL execution, wait events, and errors, helping identify bottlenecks precisely. They do not generate baselines or configure workload snapshots. If these are tasks for tools like IO or StatsBack, they also do not report global memory stats, which come from performance views. Foster gains session-specific insight through trace file analysis. Question 20. Illustrated by the need to optimize a database with a large OLAP workload is Wilson decides to enable a feature to speed up analytical queries by storing data in a columnar format in memory. Which feature is this? A. In-memory column store. B. Buffer cache. C. Shared pool. D. Program global area PGA. Answer. Correct answer. D. Explanation. The in-memory column store accelerates analytical queries by storing data in a compressed columnar format in memory, drastically improving scan performance. Buffer cache stores frequently accessed data blocks, but in row format. The shared pool cache SUL and the SQL objects. The PGA is memory allocated per session for processing, but does not store persistent columnar data. Is Wilson's choice the in-memory column store designed specifically for OLAP acceleration? Question 21. Taking into account a scenario where Mr. Patel is troubleshooting frequent latch contention on the shared pool in Oracle Linux 6, what should be his first step to mitigate this issue? A. Increase the shared pool size and review application use of hard passes. B. Disable automatic memory management to manually allocate memory. C. Enable SUL plan management to lock plans. D. Reduce the size of the buffer cache. Answer. Correct answer. D. Explanation. Latch contention in the shared pool is often caused by insufficient memory or excessive hard passing. Increasing the shared pool size and minimizing hard passes by using bind variables is the first practical step. Disabling automatic memory management affects overall memory but doesn't target latch contention directly. SUL plan management stabilizes execution plans but doesn't reduce latch weights. Reducing buffer cache size typically worsens performance and is not a valid solution. Question 22. In the context of diagnosing unexpected query plan changes after a database upgrade, Johnson uses a tool that captures execution plans and enforces plan stability. Which tool should she employ? A. SQL plan management to capture and fix plans. B. Automatic shared memory management to tune SEA. C. Active session history for session snapshots. D. StatsBack for historical snapshots. Answer. Correct answer. B. Explanation. SUL plan management (SPM) is designed to capture execution plans and enforce stability by preventing unwanted changes. Automatic shared memory management tunes memory allocation but does not affect execution plan stability. Active session history provides detailed session activity but does not manage plans. StatsBack captures performance snapshots but not plan enforcement. Is Johnson's focus on plan stability aligns with SUL plan management? Question 23. When faced with a high number of physical reads impacting performance, Lee suspects inefficient buffer cache utilization. Which strategy best helps him analyze and address this? A. Examine vBuffer pool and vBuffer cache to monitor cache hit ratios and adjust sizes accordingly. B. Increase PGA size to reduce hard passes. C. Disable automatic workload repository snapshots. D. Use SQL Tuning Advisor to fix plan regressions. Answer. Correct answer. C. Explanation. Buffer cache inefficiency is best diagnosed by analyzing buffer pool statistics and cache hit ratios through views like vBuffer pool and vBuffer cache. Increasing PGA affects memory for sorts, not buffer cache. Disabling OR reduces performance data collection, hindering diagnosis. SQL Tuning Advisor optimizes SQL statements but doesn't directly impact buffer cache utilization. Thus, the best action is to monitor and tune buffer cache parameters. Question 24. Given the circumstances of a system with heavy parallel execution, is Martinez notices significant latch contention on the library cache. What tuning approach should she take? A. Increase shared pool size and minimize hard passes by using bind variables. B. Increase PGA size to support sorting. C. Disable automated maintenance tasks. D. USUL Access Advisor for indexing. Answer. Correct answer. A. Explanation. Latch contention on the library cache often results from frequent passing or inadequate shared pool size. Increasing shared pool memory and encouraging bind variables to reduce hard passes alleviates contention. PGA size tuning focuses on memory-intensive operations like sorts, unrelated here. Disabling automated tasks can disrupt maintenance. SQL Access Advisor helps indexing but does not address latch contention. Therefore, increasing shared pool size and bind variable use is recommended. Question 25. Under the assumption that is Roberts wants to monitor and compare database performance before and after system changes with minimal manual effort, which Oracle feature should she implement? A. Automatic workload repository for automatic snapshot and report generation. B. SUL plan management for plan stability. C. Active session history for live session data. D. Trace files analysis for detailed diagnostics. Answer. Correct answer. B. Explanation. Automatic workload repository automates snapshot collection and generates performance reports, simplifying before and after comparisons. SUL plan management focuses on locking and evolving execution plans but does not provide comprehensive performance snapshots. Active session history captures session activity but is more transient. Trace files are useful for detailed investigation but are not practical for baseline comparison. Therefore, automatic workload repository best meets her needs. Question 26. Throughout the course of a performance investigation, Mr. Nguyen is advised to focus on DE time as key metric. What does a DE time represent? A. The total time spent by all database sessions processing user and background tasks. B. Time spent waiting for disk key only. C. Time spent executing background database maintenance jobs. D. CPU time utilized exclusively by the database server OS. Answer. Correct answer. C. Explanation. DE time represents the cumulative time all sessions spend doing work, including user queries and background activities. It is a holistic workload measure. It is not limited to disk key await times or background job time alone, nor is it just to EPU time. Understanding DE time helps prioritize performance tuning based on total database workload, making it a comprehensive metric for system administrators. Question 27. For many years, ISCHEN has relied on Oracle's SUL Tuning Advisor. What is a core benefit of this tool? A. It analyzes execution plans and recommends specific SQL improvements automatically. B. It manages memory allocations between PGA and SGA. C. It collects performance statistics for historical analysis. D. It captures execution plans to prevent regressions. Answer. Correct answer. D. Explanation. SUL Tuning Advisor analyzes problematic SUL statements and suggests improvements like writing or indexing. It does not manage memory allocations. That's AMWA ASM. Collecting performance statistics is the role of our or StatsBack. Capturing and preventing plan regressions is managed by SUL plan management. The core benefit of SUL Tuning Advisor lies in proactive SUL optimization. Question 20. When evaluating the merits of automatic memory management, Mr. Wilson notes that it adjusts which of the following automatically: A. Sizes of SGA and EGA memory components dynamically at runtime. B. Execution plans used by SUL queries. C. EO buffer cache size exclusively. D. Number of worker processes. Answer. Correct answer, B. Explanation. Automatic memory management dynamically tunes memory allocations across SGA and EGA to optimize database performance without downtime. It does not adjust SQL execution plans. That is handled by the optimizer and SBM. Buffer cache size is part of SGA, but AM manages overall memory, not just buffer cache. Worker processes are controlled by process management parameters, not management. AM's primary function is dynamic memory tuning. Question 29. The fundamental question is, Istio Garcia is analyzing an I report and sees the EPU age is low but wait times for D. For sequential redo are high. What should he focus on next? Investigate EO subsystem performance and disk latency. B. Increase PGA size to reduce CPU age. C. Disable automatic workload repository to save resources. D. Tune shared pool to reduce latch contention. Answer. Correct answer, A. Explanation. D. Fit sequential read waits indicate waits for single block reads usually related to index reads or queries needing fast random EO. High wait times here suggest disk or EO subsystem bottlenecks. Increasing PGA size does not affect EO wait times. Disabling I removes critical diagnostic data. Shared pool tuning addresses passing unrelated to EO waits. Istio Garcia should focus on EO subsystem and disk latency analysis. Question 30. Upon closer examination, Is Lopez wants to use real application testing to verify the impact of a system upgrade on SQL workload. Which two components does this feature include? A. Database replay and SQL performance analyzer. B. Automatic memory management and shared pool tuning. C. SQL Access Advisor and SQL Plan Management. D. Active session history and StatsBack. Answer. Correct answer, A. Explanation. Real application testing includes database replay, which replays real workloads on a test system, and SQL performance analyzer, which evaluates SQL workload performance impact. These components help assess changes before production deployment. Automatic memory management and shared pool tuning deal with memory, not workload replay. SQL Access Advisor and SQL Plan Management optimize access paths and plans, not workload testing. Active session history and StatsBack provide monitoring and snapshots, but are separate from real application testing.